Okay, let's get right into it. We have all been there, right? You're on a super important call, maybe you're driving, and then poof, it's gone. Total silence. The call drops, your music stops streaming, the map just freezes. We all blame it on a dead zone, but what if I told you that whole idea is, well, it's mostly wrong? Today we're going to pull back the curtain and find out why your connection actually vanishes.
This is the worst. You look down at your phone and it's practically taunting you. 4, maybe even 5 beautiful bars of 5G. You should be flying, but you can't even get a single web page to load. How is that even possible? It's one of those modern frustrations we all share, and it points to a story that's way more complicated than just, not having enough signal.
So yeah, you've hit a dead zone. But it is not the simple empty space we all picture in our heads. See, according to the network engineers who build this stuff, a dead zone isn't just one thing. It's actually a complex kind of failure that comes in a few different and often totally invisible flavors.
So, let's break this down. The engineers who live and breathe this stuff, they see 4 main ways your service can fail. And if you can understand these, you'll finally get why your calls are really dropping. First up is the one we all think we know.
This is the classic dead zone. The one you imagine when you're deep in a canyon or in a concrete basement or just way, way out in the middle of nowhere. The raw radio frequency energy, the RF signal, is just so weak that your phone can't hear even the faintest whisper from the network. It's a true coverage hole. Simple, dictated by physics, nothing more to it. Now this is the reason for that full bars, no service nightmare. It's what they call a soft dead zone. Your phone is getting plenty of signal. That's why it's showing you all those bars. The problem is, it's hearing signals from too many towers all at once. The engineers have a name for it: pilot pollution. It creates so much noise and interference that the actual data, the conversation you're trying to have, just gets completely lost. Your phone can hear just fine, but it can't understand a single word.
This one is just fascinating, and it happens all the time, especially if you're out in a more rural area. It's all about a massive, massive power imbalance. Your phone is a fantastic listener. It can easily pick up the powerful signal being blasted out from a cell tower miles away. But when it's your phone's turn to talk back, to send data up to that tower, its little transmitter just can't shout loud enough for the tower to hear it.
And wow, this chart just lays it out perfectly. A cell tower is broadcasting with about 40 watts of power. Your phone, it's transmitting with a tiny 0.2 watts. I mean, that is a wild difference. It's like the tower is talking to you through a giant stadium sound system, and your phone is trying to reply by whispering back. This is exactly why you can have a full set of bars, but you can't even send a simple text message.
And last, we have the ghost. This is the dead zone that isn't really a place at all. You could have perfect coverage from Tower A and perfect coverage from Tower B, but if the network botches the handover as you move from one to the other, your call just drops into a black hole for a second. This happens all the time when you, say, round a sharp corner on the highway and the signal source changes in a flash.
So if the network is this complex, how is it even measured? Well, to get that, we have to understand this really crucial difference between what's called the ground truth, the entire RF environment, and the very, very limited picture your phone is actually allowed to see. Okay, look at this. A professional scanner is like a super detector. It sees everything, every single signal from every carrier that's in the air. It defines what's potentially possible for a connection. Your phone, though, it's basically wearing blinders. It only measures the specific frequencies and towers that your carrier tells it to look for. It's a completely biased observer, which means it could be sitting right next to a perfectly strong, usable signal from another tower, and it would be completely and utterly blind to it.
This quote from an engineering playbook just sums it up perfectly. Scanners define potential coverage, UEs define realized coverage. And that UE just stands for user equipment. That's your phone. It means there's this huge gap between what's actually possible out there and what your little device in your hand actually manages to achieve.
So if we can't trust our phones, and these failures are basically invisible, how do engineers even start to fix them? Well, they have to become these high-tech ghost hunters, basically, using a very specific and pretty cool method.
They actually call it the hunter-killer method. Step 1 is the hunt. They use these massive pools of crowdsourced data, think user complaints, speed test apps, to find big areas where things seem to be going wrong. Then comes the kill. They send engineers with those powerful scanners right into the heart of that zone for a deep forensic analysis. And finally, they mash the 2 datasets together to confirm what the real problem is, and then hopefully engineer a fix.
Okay, so what does all this complicated engineering stuff mean for the phone that's sitting in your pocket right now? Well, it means that sometimes, without even knowing it, you might be creating your own personal dead zone.
Check some of these out. They're pretty wild. That forest trail where you have great service in the winter? It could be a total dead zone in the summer, because leaves full of water literally soak up the signal. That awesome panoramic sunroof on your car? It means the roof can't act like a giant antenna anymore. Your phone overheating can cause it to shut down the modem to protect itself. And yep, body loss is a real thing. Just holding your phone the wrong way can be enough for your body to absorb the signal and kill the call.
So, the most important point, the one thing to take away from all of this, is that those bars on your screen, they are a suggestion. That's it. They represent one single, simple measurement of signal strength. They tell you almost nothing about signal quality, or your phone's ability to talk back, or how the network itself is configured. They are not a guarantee.
And for some people, that guarantee is literally a matter of life and death. For first responders, the standards are incredibly high. Their networks demand a minimum signal strength that is almost 100 times stronger than what our phones need to make a call. A signal that we'd think is perfectly fine is considered a dangerous dead zone for them, because their communications absolutely have to get through.
When you get right down to it, that signal reaching your phone is the result of this constant, incredibly complex dance between raw physics, all the noisy interference of our world, and millions of lines of code that are constantly telling the network how to behave. It's this gigantic, invisible system that we all rely on, but we almost never actually see it at work.
And that kind of leads to one last big thought. The cell network is just one of these invisible, complex systems that our entire world runs on now. It really makes you wonder, if we can so easily misunderstand something as common as a dropped call, what other critical failures in our other invisible systems are we just completely overlooking?